Hi, I'm Eric Smith. I'm a distinguished member of technical staff working for Dell's Integrated Products and Solutions CTIO team. And today I'm going to provide you with an overview of the work Dell Technologies has been doing over the past several years to create a new NVMe IP-based SAN ecosystem that will provide a higher performance alternative to iSCSI and is also capable of providing a lower cost and higher performance alternative to Fibre Channel. In addition to the potential cost and performance benefits, we also see NVMe TCP enabling an entirely new class of storage services that are a perfect match for software-defined storage, as well as next-generation edge use cases. The creation of this ecosystem has required innovation at multiple layers of the storage stack, including adding support for NVMe TCP, as well as support for services that enable hosts to dynamically respond to fabric changes, adding a tremendous amount of automation to enable easier deployment of network and storage resources, and ensuring all of it is enterprise class, especially from a management and support point of view. More specifically, we started by adding support for NVMe TCP to our hardware platforms, including PowerStore, PowerSwitch, PowerEdge, with support for PowerMax and PowerFlex being added in a follow-on release. We also worked very closely with VMware as they added support for NVMe TCP to ESX70U3 and did this to ensure our solution works seamlessly from an interoperability perspective, and one that can scale up easily. Our work also leveraged and extended the existing functionality of Dell's SmartFabric Services software by adding support for the automatic formation of an NVMe IP SAN. And by doing so, we reduced the number of manual configuration steps on a per-switch basis from 2,000 down to less than 10. We did this to ensure we could emulate the way a Fibre Channel fabric automatically forms, because we believe this functionality is not only valuable, but it's also something that our customers have come to expect from an enterprise-class network used to transport storage traffic. We've also developed a new software offering called SmartFabric Storage Software, or SFSS. SFSS has been designed to ensure that hosts can automatically connect to the NVMe storage volumes that have been provisioned to them without the need for an administrator to manually configure each host to access a specific set of storage ports, as would typically be the case when using NVMe TCP or NVMe Rocky. SFSS is Dell's implementation of the standards-based Centralized Discovery Controller, or CDC, that is currently being developed by the NVMe Express Standards Organization under technical proposals TP 8009 and TP 8010. The CDC and consequently SFSS provide a number of very useful features that enable automated storage connectivity. And many of you who are familiar with Fibre Channel will recognize many of the following features. Now, because the automation we're providing is being done over an IP transport, in order to provide something like the equivalent of a Fibre Channel name server database and enable hosts to connect to it with 0 configuration steps, we had to create 3 new services. The first is a discovery service that allows a host or storage ports to use MDNS to discover the IP address of the SFSS instance that is available on that network. Once the SFSS IP address has been discovered or optionally configured, the host and storage interfaces can register discovery information, such as their NQN and IP address, with the endpoint registration service. Finally, an endpoint query service allows hosts to discover the array interfaces they are allowed to communicate with. It also allows array interfaces to discover the hosts that are potentially connectable to it. This functionality will be used when support for target-driven zoning is added in a subsequent release. SFSS also provides a zone service that provides the equivalent functionality of Fibre Channel's zone server database. By default, SFSS creates the equivalent of Fibre Channel's peer zones or smart zones and currently enforces access control via software. In the future, we will be adding support for hard zoning, as well as integration with SFS that will support that hard zoning. Now, when Dell networking, and this will of course be when Dell networking products are used. We'll also be adding support for target-driven zoning that will eliminate the need for manual configuration of zoning. Now, we've also added a service that provides the equivalent functionality as Fibre Channel's Fabric Controller that is used to distribute registered state change notifications, or RSCNs. Our asynchronous notification service handles all aspects of the asynchronous event registration and the generation of asynchronous event notifications, or AENs. These AENs would be sent to the host following something like a zoning change, or after a storage interface logs in or out of the NVMe IP SAN. On top of the new hardware features and software services that I've just described, you'll have the ability to manage both the ESX configuration and zoning configuration parameters through vCenter and Dell's Omni plugin, respectively. You can also directly manage your PowerEdge infrastructure via Dell's Open Managed Enterprise, also known as OME. And then you'll also be able to manage your storage using any of the methods supported today, including PowerStore Manager. Also in an upcoming release, we plan to give you an end-to-end view of your NVMe IP SAN's health through CloudIQ, similar to what we are doing for Connectrix products today. And finally, for those who would rather configure your infrastructure programmatically, we're in the process of creating a developer enablement portal that will enable you to download API documentation, as well as example scripts that will allow you to configure SAN connectivity from a single centralized location. To give you an idea of how these new features all relate to one another, I'll walk you through the discovery process. It starts with SmartFabric services configuring the switches and enabling IP reachability between the appropriate switch interfaces to create an NVMe IP SAN. By using SmartFabric services for this process, you can reduce the number of initial network configuration steps from 2,000 down to less than 10. Next, the server and storage interfaces discover SFSS. Now, for our first release, this will require manual configuration of the SFSS IP address on the host and storage, but in the next release, we will support the use of MDNS to discover the SFSS IP address automatically. The use of MDNS for this purpose is currently being tracked under the NVMe Express Technical Proposal TP 8009. Once the IP address of the SFSS instance has been configured or discovered, the server and storage interfaces will all register discovery information with SFSS. SFSS will then store this information in its name server database. At this point, the operator or an orchestrator could read the contents of the name server database and use this information to configure zoning. This zoning would allow servers to access only the appropriate storage interfaces. And this concept of zoning is really a critical component that enables discovery automation without causing scalability problems that would result from every server attempting to connect to every storage port in the SAN, and then manually determine if each storage port provides storage volumes for that particular server or not. That approach just doesn't scale. So that said, we know the manual process of zoning can be a bit daunting. So again, to address this, we will automate the creation of zones using the concept of target-driven zoning in an upcoming release. Once the zoning has been configured, SFSS will use AEN to notify the server and storage interfaces that a change in discovery information has occurred. And in response to this, the server will query the SFSS name server using get log page to determine what storage interfaces are available to it. And then finally, each server interface will connect to the storage interfaces returned to it in the get log page response, perform NVMe discovery to discover the storage volumes, also known as namespaces, that have been allocated to it, and then start transferring data. For our first release, we'll be supporting two deployment models. The first is a traditional SAN A, SAN B, or redundant fabric configuration that can be used as an alternative to Fibre Channel. The second is a converged network configuration that's going to be a better fit for customers that are already using an IP-based storage network and would like to take advantage of SFSS to help easily scale up the size of their deployment. I'll provide a bit more detail about both of these deployment models next. The SAN A, SAN B, or redundant fabric configuration supports not only isolation between the LAN and the SAN, but also between the different SAN instances. Each SAN instance is capable of using its own dedicated SFSS instance to provide the same type of air-gap redundancy that is provided by a Fibre Channel SAN today. For our first release, the SFSS instances will be deployable as standalone virtual appliances that will run as VMs on ESX. In our next release, we will support running SFSS embedded on Dell networking switches. And this, when combined with SmartFabric services that will also be running on the switch, will allow you to deploy an NVMe IP SAN as a drop-in replacement or as an alternative to a Fibre Channel SAN. And this is the type of configuration where we will be able to support hard zoning. For those customers who are already using an IP SAN or do not need the isolation or redundancy of a SAN A, SAN B configuration, we will also support a converged LAN and SAN deployment that supports the features you would expect for any other IP-based protocols, such as MLAC. And one point that bears repeating is this. The work we are doing to create an NVMe IP SAN ecosystem is intended to be open and support connectivity from any vendor that supplies components that are standards compliant. To this end, we have made every effort to push as much of the required functionality into the technical proposals shown here. This includes the work we have already completed to enable authentication and encryption with TP 8006 and TP 8011, the work we have done to automate discovery that is nearing completion with TP8009, TP8010, and TP8013, as well as the work that is in progress to support boot from an NVMe IP SAN, including TP8012 and TP4126. And with that, I'd like to say thank you. Thank you for your time. We hope you'll give NVMe TCP and SmartFabric storage software a try and see what it can do for you.